So in today's lecture we will just revise three topics, that is a multimeter, function generator and power supply. So all of you know multimeter is basically that are used to measure more than one quantities, means that are used to measure AC voltage, DC voltage, AC current, DC current, then resistance, like this quantities. There are two types of multimeter, one is analog multimeter, one is digital multimeter. Basically this is the one we can say as a front panel of digital display. This is our display, at that we can display here current, voltage or any other quantity. These are the different we can say as the ranges. Then this is one knob, switch knob. By using that we can change this particular knob either to millivolt, to volt. Either suppose we have to measure resistance, we take this at resistance. Then for diode checking, then for current measurement. These are nothing but the two terminals. That two terminals used for current measurement and these two terminals used for voltage measurement. One terminal is common. Range of that current measurement is from 400 milliampere to 100 milliampere. In an exam the question is like this: draw the block diagram of digital multimeter and explain it. So this is a block diagram of digital multimeter. This are consist of DC voltage attenuator, rectifier and attenuator, current to voltage converter and resistance to voltage converter. Now these important are the four blocks that are applied to ADC and then applied to counter. Now first is nothing but a function select switch, as we have to measure different parameter, means like this. In a front panel we have seen this is nothing but one rotary switch. Suppose we have to measure which quantity, according to that we can move that pointer. Same here, we are using here function select switch, that we called as a test probes, that one is connected to positive, one is connected to negative. For particular measurement we can just change the range, according to that our particular value is to be measured. Now that function select switch, suppose we have to measure DC voltage, that are applied to DC voltage attenuator. Suppose we have to measure AC voltage, just only whatever this arrow will connect here. Suppose we have to measure a DC current, just we have to change this arrow position to here. Suppose we have to measure a resistance, just we have to change this arrow to here, and then apply to analog to digital converter, then to counter and then display. Now suppose we have to measure DC voltage. These are nothing but we can say as a two test probes that are to be connected to point. One is positive that is a red, and one is negative that we called as a black. Now DC voltage attenuator is nothing but one we can say as a potential divider blocks with multiple resistors are connected in series with the block. Function of this block is to attenuate and reduce the DC voltage amplitude. Suppose we have to measure AC voltage, that we apply to rectifier and attenuator. Suppose we have to measure a current, we apply here current to voltage converter. So basically the DC unknown current is passed through this known resistance to produce a DC voltage across it, that is proportional to DC current. Then apply to ADC. Purpose of ADC to convert analog signal into digital signal, and then apply to counter and then to display, means whatever the value required we can display it on display. So this is digital multimeter. This is very important topic. After that next topic is these are the applications: AC DC voltage measurement, current measurement, resistance measurement, diode and transistor testing. Next one is function generator. Now as the name indicates, function generator that are used for to generate a different waveform, such as sine waveform, triangular waveform, square waveform, ramp waveform, like this waveform. Now this is a function generator. This having two knobs. One is a frequency control, one is duty cycle control, amplitude control. Now just function generator generate different waveforms: square, sine, and here triangular. Also we can say ramp waveform. Now there are two knobs. One is frequency control knob, one is duty cycle control knob, and this is amplitude control. Now this is a block diagram of function generator. In the block diagram, as we have seen, this is our integrator, this is Smith trigger, this is sine wave converter, this is attenuator. As you know, Smith trigger will generate a waveform, that is a square waveform. Now that square waveform again we apply back to integrator. When we apply square waveform to integrator will convert that square waveform into triangular waveform, and that triangular waveform directly apply to attenuator, or we can say take as a output. Same means square waveform already generated, that is applied to output side. When square waveform is returned back connected to integrator, integrator will convert that square into triangular, and that triangular waveform is taken at output side. Same sine wave converter, as we apply any type of waveform to sine wave converter, it will convert any type of waveform into sine wave, and that also connected to output. Means as per our switch, particular rotary switch, we can select any type of a waveform, that is either square wave, either triangular wave, either our sine wave converter. This is output voltage control, and this is our frequency range. So this is also very important topic, that is a function generator. In exam, question asked like this: draw the block diagram of function generator. Just you have to draw this block diagram, and you have to explain a particular block wise, means function of Smith trigger that will convert, this will generate a square waveform. That square waveform we apply again, return back to integrator, then integrator converts that square waveform into triangular waveform. Triangular waveform is IDC connected to output side, then sine wave converter will convert any type of waveform into sine wave. So this is a second topic, that is function generator. Next is the AC to DC power supply. So all of you know power supply is nothing but for converting of AC supply into DC supply. So this is just important topic. Draw the block diagram of DC power supply. This is nothing but one phase AC supply. We are using transformer, rectifier, filter and voltage regulator. As we apply here AC supply to step down transformer, this is step down, means primary windings are more as compared to secondary winding. This is our AC supply. As we are using here step down transformer, that will convert, or that will reduce to 30 volt to a lower voltage amplitude, and we are getting at output of secondary, that is our lower voltage amplitude. Then we apply that to rectifier. As we know, there are different types of rectifier. Rectifier, half wave, full wave and bridge wave. As we are using here a bridge type of rectifier, because we are getting output for both positive cycle as well as negative cycle. We are getting rectified output, that is a DC output, but this is not a pure DC, it contains some part of a AC. So again we apply that to a filter. So we are using here a capacitor filter. So as we are using capacitor filter here, so what happen, at each output of this rectifier, capacitor charges for positive half, discharges for negative half, again charges for positive, again discharges. So we are getting here output like this, that we are connecting this as a filtered DC output voltage. So this is complete filter output, but this is not a constant, as we have to want DC supply, so that is should be a straight line. So we go for next voltage regulator. So voltage regulator will convert, or we will make a constant voltage. So whatever this voltage we are getting, that make constant, that we called as a regulated DC voltage. That is AC to DC power supply. Question is like this: draw the block diagram of DC power supply and explain it. You have to draw this block diagram and you have to explain. And it's very simple. You have to draw all this waveform and all these blocks. So we can design different types of supply, means single polarity supply, then dual polarity supply, then dual polarity variable supply. Suppose we want a 12 volt power supply. So just this is one example: 230 volt AC input. This is a bridge rectifier. This is our transformer. Here we are using rectifier, this rectifier that consists of 4 diodes. After that filter is nothing but one capacitor, and then after the capacitor there is our voltage regulator. So this is 7812, means we want 12 volt supply, so we are using 7812. Suppose we want 5 volt, we are using 7805, and that are applied to output side. So this is complete, we can say, as a positive 12 volt DC power supply. Suppose we want a negative 12 volt DC power supply, just instead of that 78, what we write this as a 7912, as 78 series used for positive voltage supply and 79 series used for negative voltage supply. Exactly reverse. Suppose we want, right, like this, we want negative 12 volt power supply. What we do, same here, this is our one phase AC supply. These are two diodes. As we can use here step down bridge rectifier or center tap full wave rectifier, capacitor, and here only 7912. 79 series used for negative voltage and 78 series used for positive voltage series. So this is positive 12 volt supply and this is negative 12 volt supply. So important topics in this unit, just nothing but draw the block diagram of, first point, draw the block diagram of multimeter and explain it. Write down advantages, application of multimeter. This is the first point. Then second, draw the block diagram of function generator and explain in detail. Then third, draw the block diagram of DSO, that is digital storage oscilloscope, and explain it. Then fourth question, draw the block diagram of AC DC power supply and explain it. Also write down or draw the circuit for positive voltage supply and negative voltage supply. Next question, explain single phase auto transformer, either a step down or step up. Next one is write a short note on power scope. And the last question, write a short note on DC ammeter and voltmeter. So these only 6 to 7 questions are important from this unit. I will share again one PDF of this particular important question from this unit to you. So here we have completed our unit number 4. Thank you.